Welcome to the deep dive. Have you ever just, watched an airliner glide effortlessly through the sky and thought, how does something that huge stay so perfectly balanced, so responsive? It looks, well, simple, almost magical sometimes, but of course there's a whole world of intricate design and clever physics at play underneath that smooth exterior.
Absolutely. It's fascinating engineering.
Today we're taking a deep dive into the very heart of how aircraft move, their flight controls. These systems are, well, absolutely fundamental. Fundamental to understanding how any aircraft operates, how it maintains stability, and maybe most importantly for you, the learner, how you'll confidently approach those ATPL theory exam questions.
That's right.
Our mission today is really custom tailored. We want to give you those crucial nuggets of knowledge, simplify some complex concepts, and highlight exactly what you need to understand to build a really robust foundation in aviation. Okay, let's unpack this.
And what's truly fascinating here, I think, is that grasping flight controls goes far beyond just memorizing parts or, their basic functions.
Right.
It's really about understanding the why and the how, why an aircraft needs to respond in certain ways, how engineers have ingeniously achieved those responses, and why that mastery is just essential for safe, efficient flight.
Exactly.
And for those of you prepping for your ATPL exams, this deep dive, it's going to be invaluable. Our main source for today's exploration is The Fundamentals of Aircraft Flight Controls, which is really a foundational text.
A classic.
Yeah, exactly. We're going to extract the most important insights from this material, distill them down into really relevant, actionable knowledge, specifically for your ATPL preparation and, more broadly, for your whole journey as a pilot.
Okay, so let's kick things off with the most fundamental question, really.
Yeah.
Why do we even need flight controls in the first place? I mean, if I'm picturing an aircraft just hanging there in the air, what's fundamentally stopping it from just, tumbling out of the sky? Or conversely, just refusing to turn when you want it to?
Yeah.
What's the absolute baseline reason we even have these controls?
That's a perfect place to start. It truly boils down to two main purposes, two overarching goals. The first is all about achieving and maintaining equilibrium, perfect balance in steady flight. Think of it as reaching a state of zero moments around all of the aircraft's axes.
Zero moments, got it.
Yeah, so no undesired pitching, no rolling, no yawing. The aircraft should just fly straight and level without needing constant pilot input, regardless of its configuration, really. Flaps down, gear down, even as its center of gravity shifts slightly as fuel burns off. It's about inherent stability.
Right, just holding steady.
Exactly. And the second purpose, which is just as crucial, is to enable the aircraft to maneuver. This is about purposeful change, changing its attitude, its direction, its altitude.
Making it do things.
Right. Precisely. If you want to climb or descend into an airport or make a nice coordinated turn, you absolutely need dedicated controls to make that happen. So these moments around the axis we talk about, they are the fundamental principle behind all purposeful aircraft movement, whether it's just maintaining that steady state or actively changing it.
Okay, makes sense. So axes and moments. Let's get into those axes.
Right. And it's these three principal axes that really dictate how an aircraft moves in three dimensions. Let's break them down. First up, we have the longitudinal axis. Just picture a line running straight from the very tip of the nose right through to the tail.
Nose to tail.
Rotation around this axis is what we call rolling. That's how an aircraft banks, dips one wing or the other. And the primary control surfaces responsible for making that happen, for producing this rolling moment, are the ailerons.
Aileron, on the wings, right.
Typically, yeah. Located on the outer trailing edge of the wings. Now, while ailerons are the main players, it's worth mentioning, especially for your ATPL knowledge, that some modern aircraft, particularly jets, might also use spoilers or sometimes a combination of ailerons and spoilers to achieve or even just augment that rolling motion. We'll get more into spoilers later.
Okay, good to know. So that's roll. What's next?
Next up, the lateral axis. Imagine a line running from wingtip to wingtip, passing right through the aircraft's center of gravity.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best.